All right. Hey, good morning, Algebra 2 Trig students. Mr. Glover here with our second lesson of the week. So today, I really just want to continue working on some of the same things that you worked on earlier in the week, which was function operations and compositions. However, today, I want to change up some of the types of functions and kind of look at some different various types of functions that we can do instead of having just linear and quadratics. And then I also want to focus on something I talked about a little bit earlier in the week and really expand on it more today, which is how to find the domain of a function composition. So for today, you're going to need a pencil, of course. You might want a calculator handy. And then I posted a handout called Operations with Functions and Composition Practice. This handout is going to be kind of a combination of your notes along with your assignment. What I'm going to do is just kind of go through and I'm going to pick out a couple problems from this worksheet and work them out here on the screen. And you can just follow along with me on these particular problems. And then your assignment is going to be to finish all the other problems that are on the worksheet. So if you haven't printed that out, please do that now. You can pause the video. Or if you don't have a printer, you can just do this on your own piece of paper and follow along with me. All right, so here we go. We're going to start with number 2 and 3 on the handout. So I'm really just kind of reviewing here what we talked about earlier in the week. And I wanted to remind you that we did function operations, which was when we add, subtract, multiply, or divide two functions. And we also did function compositions, which is kind of like when we plug one function into another, which is exactly what we have here in number 2. Recall that this notation can be read as f of h of negative 3. Or in other words, you could think of this as f of h of negative 3. Essentially, we're going to plug negative 3 into the h function and then take that result and plug it into the f function. So the h function, if you look at the top of your paper, was 12 over x plus 1. So we're going to do 12 over negative 3 plus 1, and we get 12 over negative 2, which of course would be negative 6. So now that we know h of negative 3, we're going to grab our f function, and we're going to plug negative 6 into f of x. So f of x was 3x minus 1. So we're going to do 3 times negative 6 minus 1. And here we get negative 19. So we'd say f of h of negative 3 is equal to negative 19. All right, so that was a function composition. A function operation would be like number 3 if we're adding, subtracting, multiplying, or dividing. Here we are adding, and we're going to add these two functions together. So f of x, you can think of this as f of 2 plus g of 2. So we can figure out each of these separately and then add those two together. So f of 2, f of x was 3x minus 1. So we're going to do 3 times 2 minus 1 plus g of 2. G of x was 5x squared. So we'll plug 2 in to g of x. And now we're just going to evaluate this expression. And we get 6 minus 1, which is 5. And we get 4 times 5 there, which is 20. For our final answer of 25. Okay, function compositions, function operations. So let's jump down to the next section here, where we're going to do some function operations, but also talk about the domain. So the instructions here give us these functions to use. I have them at the top of the screen. But it also says find each function rule and state the domain. So I want to talk about that a little bit. So on number 7, we have f plus h of x. Now, again, you can think of this as like f of x plus h of x. Notice here we're not plugging in a specific number for x. We're just going to add the two functions together to get a new function in terms of x. So f of x was x squared, or is x squared plus 2x. H of x is 3x minus 12. So we can add these two functions together. Doing so gives me a new function which happens to be a quadratic. And I can stop right here. I've added the two functions together. I've simplified the expression. I'm really done at this point. But the second part of the question is to find the domain. And we're going to practice writing our domain in interval notation today. So this is a quadratic. It's a parabola. We know that the domain for all quadratics is going to be all real numbers. Recall that in interval notation, we would write all real numbers as all numbers from negative infinity up to positive infinity, like so. We have no restrictions for this one, right? All real numbers. Let's look at an example that does have some restrictions and how we would write the domain in that case. Jump up to number 8. Okay, same group of functions here, but in number 8 we're going to do g over f of x. Of course, this can be thought of g of x over f of x. So we can write out the two functions here, and we get x squared minus 2x minus 8, that's g of x, over f of x, which is x squared plus 2x. What we end up with is a rational expression. So as with any rational expression, I'm going to see if I can do any factoring and see if I can simplify this at all. So my next step would be to factor the top and the bottom. And so my numerator factors into x minus 4 times x plus 2. My denominator, I can just take out a GCF of x, leaving x plus 2. And look at that. We get a couple terms, the x plus 2's that cancel away, and we're just left with x minus 4 over x. Now, to state the domain here, we have to think about the restrictions of our function, just like we were doing back in our rational expressions and rational functions unit. So I need to look at the factored form back here in this step. Before I canceled away these x plus 2's, this was the factored form of my function. Here's where I can see the restrictions. I can see that x cannot be equal to 0, and here x cannot be equal to negative 2. So these are my two restrictions. Now, in the past, we've just listed these restrictions and been done. But in these problems, they're asking us for the domain, and we're going to write the domain in interval notation. So you can think of this as like the domain is all real numbers except for these two numbers, right? If I was to graph this on a number line, I'd have some number line here, negative 3, negative 2, negative 1, 0, 1, 2, and so on. If I was to graph the domain of this function, it would be all real numbers, but I'd have a hole here at 0 and another one at negative 2. But all the numbers in between these two would be part of the domain. Everything above 0 would be part of the domain, and everything below negative 2 is part of the domain. So if we're going to write this in interval notation, we need to write an interval for all three of these intervals here. This is one interval, another interval, and a third interval. So, jump over here. My domain for g over f of x would be given by the intervals negative infinity up to negative 2. And we use a capital U, that stands for union. It kind of means like along with the interval negative 2 up to 0. Do another capital U, stands for union, along with the interval 0 up to positive infinity. Ooh, that was not a very good infinity. See if I can fix it. That's a little better. Okay, so if there are two restrictions like this, x cannot be -2, x cannot be 0, that actually creates three intervals in our domain. From -infinity up to -2, -2 up to 0, and then from 0 up to +infinity. Okay, go ahead and flip your paper over to the back side. And I want to look at number 16 and then number 18 because it's really related to that question. On the back side, you're going to do some more function compositions. And you're going to be asked at the bottom of the page to find the domain of a couple of them. So I want to do one of these with you guys so we can talk about how we find the domain when doing a function composition because it's a little bit different than if it's just a function operation like we saw in the last problem. So for number 16, here they just asked us to find f of g of x. Remember, this can be thought of as f of g of x. So we're going to take the g of x function and we're going to plug it into f. Here's the g of x function. We're going to plug that in to the x in f of x, which will give us 4 over x squared plus 3x and then plus 2. Now I notice that denominator. I could really stop here, right? This is my answer. This is the new function. But I'm going to go ahead and factor the denominator because that's going to be helpful for us in a minute. So here we get x plus 2 times x plus 1. Okay. So number 18 then, so you do a couple problems in this first section, and then 17, 18, and 19 are asking you for domains of a couple different compositions. Number 18 happens to be the composition we just did in number 16. So it says, what is the domain for f of g of x, and express this in interval notation. Well, we just found that f of g of x is equal to 4 over x plus 2 times x plus 1. Now we can clearly see that we have some restrictions here. But before we get to that, I want to talk about how function compositions work. When finding the domain of a composition, we have to look at the domain of each of the inputting of the function that we input, and then also the function that we get as an output. So before I look at this answer right here, I'm going to go back to the beginning and ask myself, I inputted g of x. What is the domain for g of x? And if I look back up here at g of x, it's x squared plus 3x. Now again, that's a parabola, it's a quadratic. The domain there is all real numbers. Then I'm going to look at the function that is output. So after we plugged g of x in to f of x, I got this function here. Now clearly this function has a couple restrictions. Here, x cannot be -2, x cannot be -1. Once I've done that, I would look at both of my domains. I would look at the domain for g of x, and I would also look at the domain or the restrictions for f of g of x. And my domain for the entire thing, f of g of x, is going to be both of those put together. Essentially, where do those two domains overlap? Now, because the domain for g of x is all real numbers, that makes this one pretty straightforward. It means that our domain will be all real numbers except for -2 and -1. But if, let's say, the domain for g of x, the inputting function, had some restriction, I don't know, maybe x could not be -3, we would have to include that as part of our restrictions in our final answer. However, in this case, that's not the case. The domain for the inputting function was all real numbers. So we can just look at the outputted function and grab those two restrictions. Okay, so and just like the other example, we're going to have a domain here that has 3 intervals. Because if x cannot be -2 or -1, we could once again think of this like on a number line. We had 0, -1, -2, -3, and so on. If I was to graph the domain, it would be all real numbers, except I'd have a hole here at -2 and at -1. The numbers in between here would be fine. Everything above -1 would be fine. Everything below -2 would be fine. So once again, we have 1, 2, 3 intervals to this domain. So for the domain of f of g of x, we can say it's the interval -∞ up to -2, along with the interval between -2 and -1, along with the interval from -1 off to positive infinity. And in interval notation, this would be our domain. All right. I'd like you guys to try the rest of the practice problems on this handout. Give those a shot. When you are finished, I have posted an answer key, so take a look there, check your work. Please continue to email me if you have any questions. I've been getting lots of emails from people, and it's been great to stay in contact with you. Feel free to email me with math questions as well. A lot of people had some attendance questions and schedule questions. But if you have math questions or you're confused about one of the problems in the handout, please let me know, and I can even work out the problem on a piece of paper and take a picture of it and send it back to you. So please do let me know if you need help, and we can figure out how to help each other. All right, guys, that's it for the video, and sounds like I will see you again next week. Have a good weekend. Take care.